And this one I'll share with you. Okay. So I was saying that, we have two types of statistics, and the first type of statistics that we talk about is called descriptive statistics. Descriptive statistics, as name suggests, it describes what has happened. So when you want to know what exactly happened, okay, we call it as descriptive statistics. So let's say if I give an example, I say that you ask me, okay, for example, that you ask me, do you run? I say, yes, I run. So how much do you run? How many kilometers or how many miles do you run? So I can go and say, 60 days back I did 2 miles, 59 days back I did 5 miles, then I did not do anything. Then next day I did 3 miles, then 5 miles, then I did 10 miles, then I did 2 miles, then I did not do anything, was sleeping. So you don't have time to hear the entire story, right? What I did for last 60 days. Instead, if I have to answer you, what should I say? Can you make an attempt? Just try to say.
I'm
Okay.
sorry, what
No.
am I?
Yeah.
Yeah.
So you asked me, like, how many
How
how
many
many
miles
miles
do
do
you
you
run?
run,
Do you
right?
run?
Right. So instead of me telling you the entire story of last 1 year, 6 months, what I've been doing, can
Uh-huh.
I represent the entire story in one line?
Yeah, on an average, I would
On an
travel.
average, right?
Yeah,
So you
yeah,
can say that, I've been running for last 3 months. On an average, I do 4 miles every day. That's
yeah,
it. One line will describe the entire thing. Now,
yeah,
so average is a descriptive statistics metric.
yeah.
Okay. Now, when you say average, obviously it means that you would be doing more than this and you would be doing less than this. That's what average means. So if I say
Oh,
5 miles or 4 miles, it doesn't mean that every day I do exactly 4 miles.
four
It
miles.
means that someday I'll be doing more, someday I'll be doing less, right?
Yeah.
So yes, so that is one metric, and that helps us to describe the entire story. I don't have to tell you, for minutes and hours. One line, and you understand what I'm doing. So
Mhm.
okay, so that's when we use descriptive statistics. It tells us the story.
Mhm.
Okay, but before you talk about the story, we need to know the data, right? And then comes the story. So data is also based on multiple types. Okay, so the one of the type, okay, is called your numerical data, or we also call it as quantitative data, right? So when you talk about height, price, okay,
Gains,
um,
yeah, profit.
profit, exactly. So whenever you use numbers to indicate, we say numerical data. Okay. Now, numerical data can be your discrete data and it can be continuous data. Very important to understand. Okay. What is discrete and what is continuous? Discrete data, okay, data that will have a discrete value. That means, a limited value. Now, if I tell you how many people are there in your home, how
Mhm.
many chapati did you eat today? Okay, how
Okay.
many books have you read? Now,
Mhm.
these answers, okay, will be discrete. Now, it could be one, it could be 100, it could be 500, it could be 10,000, but still there is, you have discrete value one, two, three. You cannot say three and a half, 3.75,
Yeah.
right? So, continuous means every value is possible. Okay, every value is possible. So generally when we talk about how many people, how many things, okay, those becomes your discrete. If I
Mhm.
toss a coin, how many heads I'll get. If you toss coin 10 times, you can get 0, 1 or 2 or 5 or 10 or 9 heads. You cannot say
Mhm.
8.75555 heads, right?
Yeah.
So discrete values are values which are countable in nature. Okay, we also call it countable values. We can easily count. Now, count it could be two, it could be 10,000, it could be 1 million, but still you will be able to count.
Yeah.
Continuous values are also numbers, but here, as the name suggests, it can take any value. Okay. Now,
Okay.
let's say we talk about our weight. Now,
Mhm.
weight, if you see, okay, um, I give this example. Okay, first I'll give you this example, then I'm going to tell you what I what I'm trying to convey. Let's say you have a gold jewelry, okay, and you want to weigh how much gold you have, okay, what is the weight of your jewelry. You
Okay.
take that gold jewelry and you put it on a weighing scale which measures these heavy weights, right? Which will
Mhm.
have always in tens of kgs, like, you know. So if you put your jewelry on that big scale, how much it will show you?
Around the weight, like 10 point or whatever the weight is.
So 10 kg. Of course, your jewelry, maybe it could be a ring, it could be a earring, right?
Yeah.
It's not going to be 10 kg, right?
Yeah.
So how much do you think it will show you?
About 10 grams or something like.
No, so it will not have scale for 10 grams.
Yeah, it's going to should go. It's going to show you 0.000 something.
It's not going to show you that. Okay. You have your weighing scale in your home?
Oh yeah, 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 I got it. Yeah, it's not going to show up because it's not 10 kgs. Yeah,
Correct. So how much will it show you?
it's just going to show you zero.
Zero.
Yeah.
Does that mean that you don't have any gold there? No, right? Or you will not throw it away, right? Saying that, oh, it does not have any gold and you will throw it away, right?
Yeah.
Because you chose a wrong scale, correct? It's
Yeah.
showing zero because you chose a wrong scale. So this is weight is an example of continuous value, and this value depends upon the scale. Now, if I give you a scale which has only kg or pound, or does not have decimal places, it will show you, let's say, 50 kg or 60 kg or 55 kg. It does not mean that your weight is exactly 55 kg. It means that since we cannot, it's difficult for us to track, decimal values. So for simplicity's sake, we say, okay, my weight is 55 kg, my weight is 75 kg. But if you keep on adding the decimal values, your weight will keep on changing. If I have two decimal places, assume that I stand on the weighing scale, which measures the weight of gold.
Mhm.
It probably will show three decimal places, right? So weight is an example which is actually continuous in nature. Okay. And if I ask you you know, how many people in this world will have exactly 70 kg weight, your answer would be zero. In fact, nobody has exactly 70 kg weight. Weight could
Okay.
be 69.9999997555555 something, go on, like in continuous, right? Or it could be 70.12324. Exactly 70 kg is not possible. Now your scale has does not have result, but that's why it's showing you, okay, 70 kg. So imagine, okay, now you need to understand, whenever you talk about data, okay, first thing that you have to think is whether it is discrete or continuous. Temperature. Now you take a thermometer, right? And let's say your temperature is 25 degrees Celsius, let's say.
Mhm.
And suddenly after some time it becomes 26 degrees Celsius. Did that
Okay.
mean that from 25 or the next was 26? No, it was slowly increasing. It was 25.001002003. Finally, it became 26 or 25.9, which is shown as 26 degree, right? So your value, temperature is also an example of continuous value,
Mhm.
right? Continuous value means it can take
Is
any
is
value.
percentage continuous? Something like a sales percentage, profit percentage. It is still continuous, right?
Okay. Now, if you say 30%, 40%, right? Okay,
Mhm.
it is still you're discrete, right? But as I said, you're correct. Okay, and that's what the next topic is. We'll talk about your continuous value, okay, is represented as interval and ratio. So, okay, so numerical type can be discrete continuous, and continuous can be your interval data or ratio data.
Okay.
Okay.
Ratio is
If
percent.
ratio is percentage, yes. Okay. So ratio is percentage. So the question that you asked, yes, it is continuous and it is ratio. So like, 3 by, or maybe, you have this 10 by 3, for example. Okay, 10 by 3 is a ratio, right? 10 is to 3, 10 by 3. You have 3.3333, so on, right? So when you say ratio, it can take any value. You are not restricting it.
Mhm.
Unless until, let's say, denominator is always 10, then it becomes easy. Then it's no longer a continuous. But generally, yes. So the weight example, the temperature example that I gave you, those were interval example, right? 70 kg, 71 kg, 72 kg, 73. So that's an interval example. Interval is where
Age,
the
age,
sorry?
age is also
Exactly.
interval.
Yes. Age also. Yes. Age is also continuous and interval. Yes. Ratio is when you represent in
Date is
something.
discrete.
Age is continuous, right? You don't become, today you are 20 and suddenly tomorrow you don't become 21.
No, no,
So
I'm saying date.
no, see,
Date is
date
date
is a
form,
different.
it's not
No,
numerical.
okay,
Yeah.
okay, okay. So date is neither, it's not at all numeric. Okay, date is another type on itself.
Yeah. No,
Okay,
I'm asking this question because in Tableau, I mean, as soon as you like pull in like a date column, you for all of these you have an option as continuous or discrete. So, I mean, this is not the same as that, right? That
correct, correct, correct. It's not same as that. And date, if you say, it'll give you option like quarter, year, month, week, day, right? So date itself is a different type. So when I say types of data, so one is your numerical data, other is your date time data.
Mhm.
So date and time is in itself is a different data type. Yes. Okay. So that's your continuous and interval, and you have interval and ratio. Okay. So this is a ratio. Okay. Okay. So this is theory. I'm going to skip this. Next one, second type of data, okay, is your categorical data. Categorical data, also called as, okay. Now this is one way of representing your numerical data. You plot a scatter plot. Okay. So let's say I want to understand how the grades are given based on the hours of we no hours of hours a student studies in a week per week, right?
Mhm.
So let's say this student studies for maybe 11 hours and has got 33 marks or 20 marks. This fellow has studied for 20 hours and has got 70 marks, something like that, right? So, so this is one example, and we'll talk about it. Okay, I'm just trying to build up for the visualization, but yeah, we will. You're expert with it. My job is to tell you why and when we use some of those 3 4 graphs which are important from machine learning perspective, like scatter plot, your box plot. Um,
So here like ours, so here like the grade scored,
it's
right?
like percentage of marks.
Yeah. So that is continuous.
Okay, okay. Now, see, it can be for both continuous or discrete, right? Scatter
Mhm.
plot can be done for both continuous or discrete. Okay, and grades will depend, right? Now, grades is generally your ratio, isn't it?
Yeah.
So it
Yeah.
is a continuous data,
Mhm.
right? Yes. And number of hours, if you say, okay. Now, assuming that we are talking only in terms of, discrete, right? Because we are manually measuring. If it is
Mhm.
automatically measuring, then it will be continuous. But you are manually measuring, right? 5 hours, 5.5 hours. We don't say, if somebody asks, right, how many, you don't say 5 hours and 11 minutes and 20 seconds,
Yeah.
right? You generally say 5 hours and 15 minutes, 30 minutes. You generally count in terms of 15 minutes range,
Yeah.
right? So that becomes discrete. But if you want to be very precise, then it becomes continuous. So it also depends upon how you want to read it, right?
Okay.
Okay. So now the next type I told you is your categorical values. Okay. As the name suggests, here we talk in terms of categories, right? So in categorical also there are different types of categorical. The two main types, one is called nominal and other is called ordinal. Now, see, there's slight difference between the similarity also. Categorical means countable and discrete is also countable. Okay. But in categorical, values repeats,
Okay.
right? That's why we call it as qualitative. Now, for example, gender, right? Male, female, or
Mhm.
region, north, south, east, west, or car names, Maruti, Tata. So if you have a, generally when you see a form, right, drop down, right,
Yeah.
or when you select from given values, those are your categorical values, right? So you're saying that maximum values can be 5 or 10, it could be 100 also, okay? But it cannot be more than 100 and values will repeat, so those are called categories or categorical values. And
Mhm.
it can be two types, nominal and ordinal. Nominal is where there is no particular order. There is no order that you can associate with the values. For example, male, female. Now, whether I write male first or female first doesn't really matter, right? Both are equal.
Mhm.
Um, region, whether I write north first or south first or east first or west first, doesn't really matter. Maruti, Tata, right? Mahindra. Okay, again, same thing. Car makers. Doesn't matter which name you write first and which order you put, right? So I can put north first and east second, and there's no rule as such. Now, in ordinal, as the name says, ordinal comes from order. Okay, there has to be, or nominal means nomination. It's only a nomination. It's only representation. Okay, it's only to nominate, represent something. Okay, ordinal is where order is important. So you have like poor, fair, good, very good, excellent, right? Rating. Now I cannot say poor, excellent, very good,
Yeah.
fair, good, right? Either you say excellent to poor or poor to excellent. You cannot
Mhm.
just put anything anywhere. Order is important. This is also categorical, right? Only five values. Five
Mhm.
values will repeat. So it is categorical. But here, the order in which you put becomes important. So you actually put them in the order. Grade. You say A, B, C, D, E or E, D, C, B, A, right? Increasing or decreasing order. I cannot
Mhm.
say C, E, A, B, D, right?
Mhm.
Preference. First, second, third choice, right? You cannot say second as first choice, third as second, and first as third, right? So these are where, okay, there is an order. So it is not continuous, okay? We don't know in numerical, okay, continuous or discrete, you will know how many times. For example, if I say 40 and 20, 40 is twice of 20,
Yeah.
right? Okay, but in this case, you don't. I cannot say that excellent is twice or 10 times of poor. It doesn't.
Yeah.
We cannot say that,
Yeah.
right? So yeah, that's another difference between the numerical and categorical. Okay, so numerical you have discrete and continuous. Continuous can be interval or ratio. Your categorical can be nominal or ordinal, right? These are two main important topics of or data that we generally talk about. Apart from that, you will have, as you said, date, date data, text data. Okay,
Yeah.
so text data is also important, and you have this NLP analysis. NLP is natural language processing, right? When you start typing, and Google will start recommending for you,
Yeah.
that's called text analysis. Okay. So you are analyzing the text. So text is another type of data. Time series. So time series is the data where you have numerical data along with time. Okay.
Okay.
So if I ask you, let's say you run a business. I ask you what's your income. So
Mhm.
along with my question, when I ask you what's your income, I should also ask the timeline in the sense, what's your today's income? What's your daily income? What's your monthly income? What's your weekly income? What's your annual income? Income doesn't mean anything. Annual income has a meaning. Daily income has a meaning. Weekly income has a meaning. So number along with time is called time series data. Okay. Profit, sales, right? Sales. What is your sales? So you'll ask, are you
Over a
talking
period
about
of time.
over a period of time? Exactly. Okay. So time is also, time interval is also part of your data. Okay. So we call it as time series data. And of course, you have date time data. But mostly our focus will be on the first two type. Okay. And we will talk about other two also, but not in detail. But first two type,
It's time series and the other one is LLP.
yeah, we will discuss little bit, but more focus will be on the first two, the numerical and the categorical.
Okay.
Okay. So this is your introduction to data type. Now
Okay.
let's start with our discrete statistics. So discrete statistics, as I said, no, sorry, descriptive statistics, as I said, this has set of metric which will help us to know the story, right? Which will tell us the story. So, okay, the first thing that we will talk about is called measure of central tendency. Okay, central tendency. So here you have three important metrics. These are mean, median, and mode. So mean is exactly your average, isn't it?
Yeah.
So mean is exactly your average. Then median is mid value.
Mhm.
Okay, median is mid value. So if you have, say, let me talk, use Excel and talk about Excel. Oops. Okay. So let's say I have, so to find median, since it's the mid value, you have to put it in the order, right? You have to have increasing or decreasing order or something. So
Yeah.
let's say I have number like 20, 25, okay, 20, 25, 25, 30, 30, 30, 35, 35, 40, 40. Okay. Let's say I have these values. Okay. So what is the mean of these values? Mean will be average, right? So we say average.
Is
Oh,
average
oh,
and
yeah, yeah, I realized it. Sorry. I realized it.
yeah. So
Now
the
can you
mean,
see the
yeah, yeah. It's the average of everything added together divided by 8. And the median is the average of, I mean, it's just 30 here.
okay, yeah, exactly. Okay. So if you have odd number, so you have four number this side and four number this side here.
Yeah,
So
then it's going to take the average of the middle two numbers.
middle two numbers, median. Perfect. So you have mean,
Median.
median is also 30. Mean is also 30. We calculate it. Okay. So
Okay.
average of this is also 30. Median is also 30. And what is mode?
I don't remember.
Mode is the maximum occurring value.
Okay. Maximum occurring value, which is 30 again. Yeah.
Which is 30. Right? Right. So if you say this data is normal, when you talk about normal data, okay, okay, to start with, every data is normal generally, okay, and when you start creating biasness, then that's what normal data doesn't become normal, okay. So if you see that normal, okay, you see, okay, your mean, median, mode, all three are same, okay, mean, median, mode, all three are same. Now question comes, what is the significance of each of these, isn't it? So you know the significance of mean. You just told me, right? In the beginning, what mean is. You said that the whole story can be represented with one mean, right? So mean is one single value. Mean is one single value that can represent the entire data set. So if I have to represent the entire data set, I can simply say mean of, right? And then I'll say, okay, 30 is 30 is number that represents the entire data set. Okay,
Mhm.
fair enough. Then what is median? Median is also, okay, median is also a number which can represent the entire data set. Now, if
How
mean, sorry,
median is just taking the average of the middle number, right? Like what if the first few
right. So see, middle
the
number
last
means
one is
what?
less
No,
than
so middle number means what? There are equal number of numbers on the left and on the right.
yeah, like
It
what if
is
in
your center number, right?
yeah,
Which
instead of
represents both the side.
yeah, instead of 2025, how about we have 2, 3, 4, 6, 30, and then 60, 70, 80, 90. So it's not the right data, right?
No, same thing, mean also we are saying, no? Mean is also 30 only, no? Then why didn't you get that out when you talk about mean?
Yeah, mean is like I mean it's the average of all the numbers together.
Correct. So
Yeah,
see,
the median is not that.
what we discussed about mean was mean will mean means that there are some numbers above also, there are some number below also,
Yeah,
right? Now
yeah.
median says there are numbers above also, there are number below also. Same thing.
Okay,
And there equal number of numbers above, equal number of numbers below.
okay,
Right? So in a way, if you see, this is also representing your data set,
okay.
right?
Yeah.
See, we don't know maximum, we don't know minimum, we don't know how many numbers. If you talk
Mhm.
about average or mean, okay, we don't know how many numbers are there in the data set. We don't know what is the minimum, what is maximum. We
Mhm.
don't know how many are what types. We just
Yeah.
know that if you do average, you get this.
Mhm.
So median also says that there are equal number of numbers below and equal number of numbers above.
Okay.
Okay.
Yeah.
So if I say median is 5 kilometers, that means okay, equal number of numbers below 5 and equal number of numbers are above 5.
Yeah.
Right? Okay. So this is your median. Mode does not get changed. Mode is same. So generally, we don't talk about mode. So in descriptive statistics, mode is not that significant. Okay,
Mhm.
mode is not significant. But you know that when it is normal, all three are kind of same value.
Mhm.
Okay. So when I say normal, what happens when things are not normal, when things are abnormal? Let's say I added a value here, 900. Now, most of the values are 2 digit. Suddenly, I see a 3 digit that too a high value.
Yeah.
Okay. Most probably, this number doesn't belong to this, isn't it?
Mhm.
Right? If you talk about, let's say, marks, most of you have got 2 digit marks, so one gets 3 digit marks. Something is not okay, not right. So this is called as outliers, isn't
Uh-huh.
it? Something that does not go along with the other data set. It could be right, it could be wrong. Okay. Sometimes outliers are used to figure out wrong values, but sometimes it could be correct also.
Okay.
Okay. Now, now if we add 900, what happens to mean median mode? Your mean,
Mean will change, but the medium will remain this. Maybe, yeah, it may or may not remain the
yeah,
same.
in this case, it will remain because even if you go towards the right,
Yeah,
it's
yeah.
30 only.
Go to it's going to be 30. Yeah.
30 only. Now, what did I do? I did median. I should do average. 117. Now you see. Okay.
Mhm.
Our assumption is good. Okay. Median is number that is representing the entire data set. Now, if you look at this data set, 117 is the mean. Now, if you do not see the data set, if I do not show you the data set, okay, let's say the data set is hidden to you, and if I tell you that data set has a mean of 117, if I tell you the data set has a mean of 117, you'll start thinking of numbers like 50,
Yes.
90, 120, 130, 140.
Yeah.
You will not talk about 20, you will not talk about 900. So see, mean can give you a bad information when there are outliers. See, if there are no outliers, then it doesn't mean whether you talk about mean or median.
Yeah.
When you do not have outliers, it doesn't matter you talk about mean or median. Both will give you similar. Okay, I have taken data such a way that both are same, but it could be different also, right? But it will not be much different. If it is one is 30, it could be 32. So now 30 and 32 does not have much difference.
Okay.
But 30 and 117 has a lot of difference, isn't it? So now if you see in this case, probably talking about mean is bad idea. Okay. Median can be a good idea. Because if there is one high number, it should not impact the overall understanding. Right? Let's say Sachin Tendulkar, if he plays very well in every match, one match if he got out and dug, zero score, it should not have much impact. Everybody has one or two or three bad days. So just because you have 10 great score and one bad score, you can't be talking about one bad score. Okay, you can't be talking about one bad score. Okay, it is 1 out of 10. You have to look at other 9. Okay, so same thing here. What median says is, just because you have one outlier, we should not change our opinion about the data set. So it does move towards the right. In this case, it's going to be average of 30 and 30, correct? Which is going to be 30 only. Okay. So your median is not changing, but mean is changing by much. It's almost like 4 times. You're getting value 4 times. So outliers does not impact your median values.
Okay.
Right? So when you have outliers, we generally tend to go by median.
Okay.
Okay, we generally tend to go by median, and that's the median value in this case.
Okay.
170. Okay, so so we have mean, median, mode. One more thing you see, when you have outliers on the higher side, on the right side, your median and mean both will run towards right. The median is also going towards right, isn't it? It's taking average of this 30 and 30. Mode is not impacted. So mode doesn't get impacted by outliers. Outliers means it's rare, right? It will be like one value. Now,
It's
for,
me, right? The 900 mode.
sorry,
So if you have an outlier, it's going to show the maximum value as 900.
not maximum occurring value.
Maximum occurring value. Okay. Okay. Yeah.
Right? Yes, not the maximum. So max is maximally. We'll talk about in another section that max is maximum, mean is minimum, but maximum occurring value. Okay, maximum occurring value will be always towards the center, not towards the end. Okay,
Okay.
it is towards the center. So, oh my God, it's raining heavily and there is the thunderstorm. Okay. So, so when you have an outliers, both average, mean and median, they are going towards right. correct? Okay, but who's running faster?
Mean.
Mean. Both are running towards right. Okay, we have a new value on the right, so let's go and check. Okay, median is like, okay, I will think and see. Mean is like running fast, and this concept will be helpful when you get into distribution later. Okay,
Okay.
when you talk about probability. So you see that one outlier will push median, will change the median value by a larger number.
Mean
Okay.
value. Mean value.
Yes. Now, if we talk about mode, your mode is not changing at all.
Mhm.
Okay. For mode to change, 900 has to come at least three times. And outliers will not come in groups. Outliers, as the name suggests, only, okay, outliers, right? Rarely it happens.
Yeah.
Things which rarely happen will never impact your mode. So mode will not get changed when you have outliers on either side. Okay, you can have outliers on the lower side also, right? Left side also.
Yeah.
So if you have outliers on the left side, your mean will run faster towards left,
Mhm.
but median will go little bit slowly towards left, and median mode will not at all move.
Okay.
Okay, so this is the relationship between mean, median, mode. All three are measure of central tendency. All gives us the center value, where the center is of a given data set. What is the center of the given data set? Is given to us by mean, median, mode. All three. But of course, they have, okay, their own meaning. Now going back to the, I'm back on the book. Okay, can you see?
Yeah.
Okay, so this is mean, median, and this is mode. Okay, so in this case, you see we have five three times. So mode is five. Now, if you look at, okay, we'll take two school A and B. Okay, and you compare the marks obtained by the students of school A and school B. Okay, so you have so many values, right? It is very difficult to read, understand, uh, analyze so many values. So what we do is we calculate mean, median, mode. So when you calculate mean, median, mode, this is what you get: school A and school B. So now looking at it, what does it tell you? What do you understand from this?
So on an average, school A, those are a score. So school A gets a score of 73.9. Um, the so there are like values above and below 70. Um, and the most repeating value is 70.
Compare A and B.
Compare A and B. Okay.
Yeah.
Uh, so I see that overall, yeah, I mean, even though the overall average of school B is less, but a lot of students are either like I mean, are like either getting high scores or like less scores. I mean, there are like a lot of students who are getting like 99. The average is less compared to A because there is extremes in like scoring. Like I mean, I see a lot of students uh, getting like high score and I mean either high score or I mean or like lower scores in school B.
Correct. Okay. Right. So if you see their average mean, there is not much change, but a lot of change in their median and mode, right?
Yeah,
So
yeah,
yeah, it tells a story which is very similar to what you said.
yeah.
Okay, and that's the purpose of mean, median, mode. Okay, when you have continuous values, then what do we do? Okay, 5, 5.5, 3, 3.5, 3.8, 3.9. Then what do we
Mm.
do? So in this case, we create histogram. Okay, So we group the values. We say 0 to 9, 9 to 19. Now this range has to be equal. I cannot say 0 to 10 and 10 to 90, 90 to 500. If you're doing it, you're doing, of course, that is also grouping, but that is not a statistical grouping. Statistical grouping means the distance between the group has to be same.
Okay.
Did you understand this? Right? And then when you create a bar graph, that is called as histogram. So bar graph of range is your
Hello.
is your okay. This is how
Background.
you represent the data. Yes.
Okay.
Okay. Because it's a continuous, right? And you cannot have continuous values.
How do we how do we determine like what data to represent as histograms and then what data to represent as a scatter plot or something like, I mean, based
Correct.
on
Correct.
how do we decide?
So yes. So see, and we'll talk about it again later also. When you want to find the relationship between two numeric values, scatter
Okay.
plot has x and y axis,
Two
right?
no. Okay.
Scatter plot has x axis as well as y axis. So we're
Y-axis,
talking
yes.
about values on x and y. So when you want
Mm.
to compare two values,
Okay.
it is median.
Hello.
Okay. So when you are trying to compare two values, it's better we draw a scatter plot.
Okay.
Then you said something, histogram.
Histogram.
Histogram is to represent many values. You have more values, but you have less scale to represent.
Mm-hmm.
Then you group the values and represent as per the group that you have created.
Okay.
Okay. Um, then what else we have seen? These two we have seen, right? Yes, we'll do. Okay, we'll do three, four graphs are very common. We'll do okay, which is like foundation for machine learning. Okay. Now, if you see temperature versus sales, so there is a shopkeeper. Okay, small
Okay.
ice cream shopkeeper. He wants to understand how much
E-
daily sale is happening. Okay, maybe he has to take a break. He has to go somewhere. Okay, so he wants to know which day is going to be best day because when he goes, he has to close his shop and go, right? So you
Yeah.
will not close your shop on the day when you expect to get big sale, but you will
Yes.
stop. You will not sell on the day where you are expected to get smaller sale, right?
Yeah.
So this is what we have: ice cream sale versus temperature.
Yeah.
Okay, so this is another relationship. Now I'm going to skip this arithmetic harmonic, not okay. And you read this, okay? This is based on what we discussed. I told you mean, median, mode, which is better. Obviously, mode is very least significant for analysis. Mean and median are both significant. So if
Mm-hmm.
data is normal, we tend to go with mean. If
Okay.
data has outliers, we tend to go with median.
Mm-hmm.
Okay, this is what this whole story talks about.
Okay.
Of course, with an example here. Okay, now data. Now you see here, if you see graph data representing like a line, it is like continuous data. Okay, and when you see data like bars, it is discrete. Okay, so this is symmetric data. Symmetric data means the data is symmetric at the center. So if you put your mirror at the center, you will get same
That.
image.
Uh-huh.
Yeah. Okay, so all these are differences. That first one is normal, which has one mode. Center one does not have mode, or everything is a mode, because all are same uni
Same.
model. We call them a uni model.
Uh-huh.
It's all uniform. Uniform. That's a uniform model.
Uh-huh.
Last one is called bi-model. It has two models. Symmetric can be this, this, or this. Generally, we talk about normal graph like this. Okay.
Okay.
And okay, we'll stop here. Tomorrow I'll
Yeah.
talk about the tail. What is tail and how to read this graph. It'll be
Okay.
easy to remember.
Okay.
Okay. So tomorrow, hopefully, we will be able to wrap up with the descriptive statistics.